Okay, so what this section is, it's identifying quadratic functions. And what a quadratic function is this right here. It's a line flipping around, and there being symmetry to it. Okay? So, vocab, quadratic function, we're going to talk about parabola, we're going to talk about vertex, we're going to talk about minimums and maximums. So it's a bunch of new stuff, right? Okay, let's look at this first example. We're looking at our x and y. Y is equal to x2, okay, or x squared. So if we're looking at this, we have a common difference on the x, right? 0 to 1, 1 to 2, 2 to 3, 3 to 4, plus 1, okay? What quadratic means is that the second common difference is the same. You remember the first common difference when it's linear, how it has to be the same versus the x and y? So if we're looking at this, 0 to 1 plus 1, 1 to 4 plus 3, 4 to 9 plus 5, 9 to 16 plus 7. So this is not linear, right? Because we don't have a first common difference. What quadratic is the second common difference. Now where we get the second common difference is taking these numbers and seeing what happens. 1 to 3 plus 2, 3 to 5 plus 2, 5 to 7 plus 2. So there's a pattern in the second common difference. Do we see that? That's what quadratic is, okay? So it's a constant second difference. If there is a constant second difference, it's true. It's quadratic, okay? Now, that's the simplest form. Now we're going to get through the rest when it comes to like standard form. So if we're looking at example 1, we see that we have a common difference of x, but when we're looking at y, 8 to 2 minus 6, 2 to 0 minus 2, 0 to 2 plus 2, 2 to 8 plus 6. Now we're looking at the pattern of the second of the actual common difference numbers. So minus 6 minus 4 plus 4, minus 2 plus 2 plus 4, 2 plus 6 plus 4. So we have a common difference of plus 4. This is quadratic. Okay? Okay, this right here is our new formula. You see what changed? Remember what I've been telling you? When you have that x to the power of 2, that means it's curving around. Okay? So we have to have x to the power of 2 for anything to be quadratic. We're not concerned about this. We're not concerned about this. This is the most important part. Are we clear? So if we're looking at this one is not quadratic. But what is this one? It's linear. Yeah, because if we added 3x to both sides, we'd have 3x plus 3x plus 5 equals 20. We have an a, we have a b, we have a c. That's going to be linear because it's in standard form. Okay? So, looking at this one right here, same thing. We need the x and y on, or excuse me, the x to one side because it's y equals ax2 plus bxc. So we need to move the 3x2 over. So we're going to do the opposite. We're going to subtract it from both sides and we're going to rewrite the problem. So y is by itself, that's what we want, minus 3x2 minus 4. Now, this is what happens in this scenario here. So our a is negative 3, our b is 0, and our c is minus 4. Okay? So c is the number, the b is whatever the number that's in front of the x, and then to the power of 2 is the first number of the coefficient inside of that x to the second power. Are we clear so far? Now, when there is not something there, it doesn't mean that it's not quadratic, okay? As long as you have an x flipping around, in other words, to the power of 2, you can have a b or a c that's nothing, that's not even there, okay? It's still a number, okay? Good so far? Good talk. Okay. So now that we covered the standard form of it, let's look at graphing, okay? So this is saying y is equal to 2x2, okay, power of 2. So anytime we don't have x's, you remember in linear how you use 0 through 4? Now we have to cover both sides of a axis. We have to go negative, we have to go positive so we can make sure that we cover what's happening within it, okay? So now the numbers we use are negative 2, 1, 0, 1, and 2. Is that clear? Because we need it to curve around, where Before, when we were just linear, we're going to hit it through 0 through 4. Now we got to make sure we go into negatives. Okay? So when we don't have domains, this is what we use. Are we clear? -2, -1, 0, 1, and 2. You just got to get used to when you don't have that, that's what you use to go graph it out. So, because this is all we have right here, okay? So we go and plug this in, we can actually solve this. But for this standpoint, I'm going to go to this because I actually show you how we solve it. But essentially, -2 goes inside here, right? So it's -2 inside parentheses. So it's -2 times -2 itself. So it's positive, and then +2, so that's 4, 2, 8. Are we clear? We're not talking about the math right now, I'm just trying to show you the graphing. Okay? So essentially, -2 being x, it equals 8. Okay? So if we're looking at this, we have our x's and we have our y's, so we're going to go plot this out. So -2 and 8, so we're going to start at -2, go to 8, then -1 and 2, -1 and 2, 0 and 0, 1 and 2, and then 2 and 8. Do we see a pattern? Yeah. Aren't these exact opposites? That's why we have to do the -2, -1, 0, because it's going to cost either the y or the x, so we actually see it. Okay? Okay, here's where we go to the vocab. 0 was right in the middle, right? So 0, 0, or origin, is what we call vertex. Now, it's not always origin. It depends on where it falls. It happens that this one is 0, 0. Are we clear? Okay, the parabola, all you need to know is that's the curve in the line. That's all that means, okay? Any questions so far? Now, I'm going to touch on minimums and maximums, but I'm going to go into it more. If you're going up, it's minimum, okay? Because that means where this point is, it can't go any lower, so it's minimum. So if it's going down this one, it's going to be maximum, right? Because down, that maximum number is going to be the highest number it possibly can. Or going up, minimum is going to be the highest number it possibly can. Make sense? So it's a lot of vocab going on, a lot of new stuff, okay? Vertex means the middle point, okay? Minimum going up, maximum going down, okay? All right, now we kind of put it all together on this one. Notice this one's 2x2 and this one's minus 2x, okay? Same math, it really doesn't matter, but what ends up happening is we have a negative times a positive when it's all said and done, which turns it negative. So we're going to go and graph these out. Notice it's exactly the same per se, except these are negative, right? So these y's end up being negative on the graph. So this one's the exact opposite of this one, right? We're still 0, 0. We still have the same points of -2 and 8, -1, -2, 1, -2, and 2, -8. So it's going on both sides of the y-axis, right? So our parabolas, where it's turning, the vertex is 0, 0. Now, if it's asking...
All graduates, please report to room 27. All graduates, please report to room 27.
If it's asking what the range of domain, the range of domain and the range of range, we know that these are going to be all real numbers, okay? And then R, the range, let's think about this. Y is less than 0, right? This is always the second number of the y within the vertex, okay? So this is saying it's less than 0. Well, isn't it less than 0? Everything is less than 0 when it comes to the range, okay? So this part is fairly straightforward. Pretty much your D is always going to be all real numbers, and then your range is going to be whatever your y is in the vertex, okay? A lot of information, right? Okay, we're going to go through it a few times. So let's look at this one right here. So our vertex is 1 and 5, right? Our x is 1 and our y is 5. So the point where it connects or curves, that upper point is what the vertex is, okay? So in this case, it's 1 and 5. Now, our maximum heading down is the y, okay? There's no math involved, right? It's just identifying where these curve at, what that greatest point is. If it's going down, maximum y. Nothing to look at, right? Because once you figure out the vertex, you have everything you need to describe everything. Are we clear? This one is a little bit different. We're plotted at 2, -5 right here, right? So we see that we're 2 on our x, down 5. So there's our vertex. Our vertex is 2 and -5. This is minimum. It's going up. It's the y, -5. Pretty easy, right? Find the plotted vertex. You have your x and y. And your y is going to be determining whether it's going up or down is your minimum or maximum. Okay? The easiest way, like I said, to remember this is that if it's going up and it's minimum, this is the minimum number. There's nothing below this where this vertex is. Where it's maximum, that's the maximum number it can be. Everything else is below that. Okay? Now, if you just remember that down is maximum and up is minimum, but having the understanding behind it of why helps a little bit. Good so far? Okay. Okay, this one's kind of the same thing, but I actually take this one from right here, and I show you the math behind it, okay? So, we have a graph. We know that we're 0, 0. It's going down, so we know what our vertex is, and our maximum is our y, which is 0, okay? Here's the graph in it as far as us graphing it. Now understand, we didn't have this. It told us this is what it was. It says x, and then y is minus 2x squared, okay? So here's the math. This x becomes -2, because remember, when we don't have domains, we just use -2, -1, 0, 1, 2. So we go insert this in here and solve it. Now, this is a negative inside parentheses. So what happens? Negative by a negative, okay? If there aren't parentheses, it stays negative, okay? So our rule applies here. That's a negative times a negative, okay? So that's -2 times -2, which is +4, then -2 on the outside, okay? Because we haven't solved for this. We got to take care of this exponent first. -2 times 4, -8. Now, I'm not going to go through this, but I showed you this math, okay? So the second part of the quadratic that's so important is that when you do this, we're looking at that common difference, right? We're -8 to 2 plus 6, 2 to 0 plus 2, 0 to -2 minus 2, and -2 to -8 minus 6. We're looking at these second numbers after we figure out the first common difference, okay? So we're going to go 6 to 2 minus 4, 2 plus 2 to minus 4, can't talk today, plus 2 minus 2 difference minus 4, 2 minus 6 minus 4. So our common difference here is minus 4, right? So we see a couple of things. We have a vertex, we have a maximum, we see it curving around, we have a second common difference. This right here is proving it's quadratic, okay? Anything with the second common difference has to be quadratic. Are we clear? So we have to do the math, right? We have to figure out what the y is so we can graph it out, okay? We can see it on the graph just like the way you did linear. You wouldn't do common difference on the table, right? You had common difference on both sides if it was in standard form or whatnot, and then you wouldn't graph it out in a formed straight line. It was linear. Only thing different here is that once you figure out the first common difference, you go to the second one. This is what it is plotted out, okay? So we see it curved around. We see that there's a second common difference. This is quadratic. So it's really not that hard. It's just a lot of new information, right? Okay, any questions on this so far? So let me tell you what you're doing today, okay? Obviously, you want to have the vocab and the notes on. That's important, okay? But I didn't give you many do now questions. I only gave you 4. There's a little bit of work involved, but not really that hard. This first one, you're going to put it in a table, okay? You're going to figure out common difference of x. You're going to figure out common difference of y. And then you're going to figure out second common difference. You're going to graph it out, and you're going to tell me whether it's quadratic or not, okay? Now, I'll tell you it is quadratic. So you get used to plotting this out. So you're going to plot the ordered pairs out, and then you're going to see whether it's minimum or maximum. I want you to label the vertex of it and tell me what the maximum or minimum is. Okay? What is the maximum or minimum?
Maximum is when like the arrows like pointing up, but it's like you could only go so high.
Excellent.
And then minimum's the lowest.
And how do you find what that is?
You just go to where it's at.
The vertex. Go to the vertex and it's your y. Yeah, that's it. Okay, so this right here, you have this equation. You're going to put this into a table. You're going to use your x's, okay? -2, -1, 0, 1, and 2. And you're going to plug it in here. Now, if you notice this equation here, what do you need to do to this first and foremost?
Minus the
Number
x
three?
on both sides.
Yeah, you need to subtract x from both sides because you need it to be a y. So what is a c in this case? If it's nothing, it's 0, right? And you can not have an x, you can not have a constant. It just ends up being 0. Okay, are we clear? So you're going to go do tables on these. You're going to show me common difference, and you're going to graph them out. You only have 4 questions. Okay? I just want you to get practice in. We're going to spend the entire week on this because I want to make sure that you know this. Cameron?
Can you actually do like one problem with us? Like actually like from just using the numbers to graph it out?
That's why I put this one up here and I put this one up here. Actually, we didn't go through this one, did we? Oh, let's go through this one. This is crucial, okay? So you see this equation right here? We have to get it in this form, okay? So looking at this, we want to get y by itself, so we're going to add plus 5x to x2 to both sides, right? Okay, so once we do that, we have our 5x2, we have our 2x, we have our 6, okay? So we have everything that we need. This is in quadratic form for us to be able to graph it. Our a is 5, our b is 2, and our c is 6, okay? So we're going to take this equation. Now this one's got a lot going on, right? -2, and we're going to plug it in and solve for it. So -2 is going to go inside the parentheses. So that's -2 times -2, right? So that's positive 4 times 5, 20, plus 2. The plus 2, -2, minus 4, plus 6, 22. Simple order of operations in this problem, okay? But if you have an x, you have to remember, you have to substitute it in both spots. You have to substitute in the quadratic part and the other side of the line. Make sense? So this is it entered. This is us figuring the number. This is it graphed out. Here's our vertex. Our vertex is 0, 6. Our minimum is 6. It's heading up. All this is right here. This is the common difference. Okay? I ran out of room. So 22 minus 9, 13. 9 from 6. Minus 3, 6 to 13, 13 to 20. So it's -13, 3, 7, 17. It's 10 with all these. -13 to 3, 10, 3, -3 to 7, plus 7, 10, 7 to 17, plus 10. Okay? So we have a second common difference. We're able to solve for it. We have all the numbers to be able to go and graph it out. So this is an excellent example of what the do now is. And by the way, this essentially is all the section in one problem. You're either going to have to put it in this form, okay? If it fits in this form, we know it's quadratic. It's just like standard form. It's the same thing, okay? But the big thing is, we have to solve this to be able to graph it out, to see where it is on the graph, okay? Are we clear? Okay, now, sometimes it's going to give you what the x's are, okay? A lot of times it won't. It'll give you an equation just like this. You've got to get it in this form, and then you have to go substitute for x to go and solve so you can graph it out. Okay? Okay? Let's make miracles happen. A lot of new stuff. A lot of new stuff. Second common difference, right? Remember that it's now x2, okay? It's flipping around. Parabola, vertex, maximum, minimum. Maximum, minimum is always the y, and depending whether it's heading up or down. Okay? But I'm literally going to lecture on this for 3 days. So you guys are going to be okay. Good talk.